Hi everyone, welcome to Mostly Math. Today we are going to be factorizing the quantum harmonic oscillator. Or QHO for short. This is one of the most important Hamiltonians to study in quantum mechanics, since every potential around a minimum can be approximated to be a harmonic oscillator, which is why it appears everywhere. This is a typical illustration that you would find in the textbooks. I'm just going to do it because I think it's cool. I think more people should know how to do it. We're going to use the creation and annihilation operators. So let's begin. I'm just going to take this operator A, which is the annihilation operator. I'm going to multiply it by its conjugate and see what we get. So we want to show that the Hamiltonian p squared over 2m plus 1/2 m omega squared x squared can be factorized as h bar omega a dagger a plus 1/2. The 1/2 we will see is going to come from the non-commutativity of the x and the p operators. And let's begin. So a dagger a is simply m omega over 2h bar. We're going to do x minus I over m omega p and x plus I over m omega p. Note x and p are hermitian. So x dagger is equal to x and p dagger is equal to p. But the a operator is not hermitian, which is the whole point of what we're going to do. So, continuing, we're going to get x squared, and this term is going to be I over m omega xp, and this one's going to be minus I over m omega px. Last term, we're going to have minus I squared equal to 1, so plus p squared over m squared omega squared. And right away, we can notice something with the commutativity of the p's and the x's. We want to rewrite it in this form. Everything else is going to stay the same, except we recognize that these two terms are proportional to the commutator of x and p. And what is the commutator of x and p? Well, every student of quantum mechanics knows it's simply IH bar. So we get I squared is equal to -1 with this term. Let's see, just a more. Which order do we want them in? P squared over m squared omega squared plus x squared plus this term minus 1 over m omega h bar over m omega. And now we just multiply the constants through. Well, we're going to have p squared on top. Let's see, we're going to have a 2, we're going to have an h bar, and there's going to be an omega. This is the tricky part, by the way. And let's see, we're going to have the x squared just gets everything. So I'm going to write this in a more illustrative manner. And multiplying the final constant through. H bar is actually going to cancel out. Everything's going to cancel out except for 1/2 half. Let's see if I did this right. X squared. Yeah. Just checking my notes. This is the part where it always gets tricky. Yeah. It should be good. And now we notice that we can factor 1 over h bar omega from this term here. Yep. Q squared over 2m plus 1/2 omega squared x squared minus 1/2. This should be right. 1/2 m omega squared x squared. Honestly, the constants and the simple multiplication are the things that always get me. Yep, you can check it yourself just by multiplying everything through. So now we are done. We simply want to solve this. So now we're going to write it in this form. H bar omega. The whole thing. So we have this. A dagger A is equal to this. Well, we can now solve for H. H is exactly what we want it to be. H bar omega. A dagger A plus 1/2, since we put the 1/2 on the other side, multiplied by h bar omega. Pretty straightforward. This is the easiest and simplest way that I know how to do it. I like this definition of the annihilation operator. And from here you can, of course, you can develop the whole theory of the quantum harmonic oscillator. Yeah, you can find more in a standard quantum mechanics textbook. I just thought this was really cool. Thanks so much. See you next time.